Today we'll be looking at dynamic memory in C++, right? So I would give an overview of what memory dynamics is, and then with an example we will illustrate further. So we have already talked about that. I think we touched on it in a previous video where we said variables are declared into static memory and we have dynamic memory for other purposes. Now, when we also talked about the runtime and compile time, right? So to just brush over them, the compile time is the pre-processing. Let's say when we write a function, and then let's say when we write a program to perform any tasks that we want, and then we start to run it, right? When I run this program, then I get an error over here. It says that expected initializer before this token, right? So what initializer did it expect? An initializer before that token. So this, I don't know what it's talking about right now, but this is an example of a compile time error. So for compile time, it is the time of the processing when the computer kind of checks if you have all the conditions satisfied. So if you have declared variables, it checks to see if you have declared them well and all other things before it starts to perform whatever task that you want it to do. And we kind of compared it to cooking. We said that before cooking, you have to have your um, ingredients. So if you don't have a particular ingredient, you have to look for it before you begin cooking. You can't begin cooking without your ingredients, or you want to perform a task and you have to have certain instruments or gadgets. You have to find those ones. If one is missing, you can't perform the full task, so you have to find it before you begin. So that's basically what compile time is. So when we kind of check out all of these errors, then compile time, then there will be no error in compile time, and so the program would run smoothly. And so when there is no error in compile time and the program runs smoothly, then we get this output. And this is now what we call the runtime. The runtime is the time of execution. So after getting all your gadgets, after getting all your ingredients, then you then start to cook. You start to perform what exactly you will be doing, right? So that's the major differences between the two. So today we're talking about dynamic memory. What relationship does this have to do with runtime and compile time? Now, when we declare variables, let's say int a, as such, let's say int a is equal to 6. Let me use this to be more precise so that you guys will kind of get the intuition. So long a, right? So what did I just do here? Long int a, right? So what I just did here is declare a variable called a. And what does it do? It just stores a value 6, right? But then with this particular data type, we specified explicitly that the computer should create a particular storage amount of storage on the memory for this particular variable. So if we just use int, it's different from long int. The amount of space that is being reserved for this particular variable is different. We touched on that on previous video and other videos as well. You can just check that to get more clarification. But with this one, there is a particular room that we want, amount of space we want this particular variable to be given by the computer. So that's why we explicitly stated this. Now, this amount of space is allocated during compile time, not during runtime. So before the program starts to execute, let's say that we come here and then we want to print out this particular variable. Before the computer starts to print out this variable, it tries to check all of these things whether they are met. It tries to check the syntax and everything to see. That's compile time, during compile time. So it is during this time that it is checking that it allocates this amount of memory to the variable we created, not during the execution. It's during the compile time. So when we run this, we don't get any compile time error because it has checked all the requirements and we met every requirement, and then it went ahead to create an amount of space. And what this space basically is I think it's at least 32 bits. That's 32 divided by 8, I think is 4. So at least 4 bytes on the computer memory for this particular variable. So let's say 4 rooms, each room is 1 byte. So 4 rooms were reserved for just number 6, for just this variable which stores 6. It doesn't store um, further information, just the digit 6. And this was done during the compile time, right? So in subsequent parts of the program, if we declare another variable, let's say int b or any other variable, and we are using memory, right? When we know that memory is kind of limited. Now, this space that was reserved, 4 rooms were reserved for variable A. Now, let's assume that this particular variable, just 6, stored 1 room. Let's assume it's 1 byte, so it stored just 1 room. It occupied just 1 room. Now, what happens to the remaining 3 rooms? They will never be used within the runtime of this program, or within the course of this program. Those 3 rooms will never be used. They will never get to be used. Why? Because we have explicitly told the computer to create this amount of space for this particular variable. So as to whether it's being used or not, we don't get to use it. It's a block memory, like blocked resources. That's what static memory is. So the variables over here are storing static memory. And this has a lot of disadvantages. We just touched on one, that for static memory, you kind of block the memory space for a variable when the variable might not store the entire space that was allocated for it. Now that brings us to what dynamic memory is. But before I really talk on dynamic memory, I want to just illustrate, run this example before, and then we get into what dynamic memory really is. Because it's really a powerful tool. When you have a bigger program, you kind of see it at work, and it really improves efficiency. So I'll just create an array. So what this is what we're going to do. We are going to create a program to request for entries from the user. So the user is going to enter a number of entries, and we're going to take those entries and just print them out. So that's basically what we're going to do. So since we will be requesting for a number of entries, it's better we store those entries in an array so that we can process them. So I'm creating an array called array1, and let's just leave an element of 0 in there, and then initialize it with those curly brackets. So this is an array. We have just declared it. We have not put in any value, so it has not yet been initialized. So this is an array. Now what do we want to do? We want to see out, enter the number of, or let's just say how many numbers, right? So how many numbers will you be entering? Right, so how many numbers will you be entering? And let's just put an end line over here. So what I want to do is I want to just use these constant values, so I don't have to be typing endl and all of that, to make it kind of easier. So I'll be copying these constants, right? And I'll be pasting them. I can paste them up here to kind of make the code look very organized. So I'll be pasting it here. Right, so we will then be using these. So the endl is now to be denoted by nl, just nl. And I think that's better. Right, so we'll print out how many numbers will you be entering. And the user would enter the value. Let's say the person would say, I want to enter 8, 6, whatever. Now, whatever number of elements the user want to enter. So let's just say, then we have to store this into a variable. So number, let's store it in a variable number. Before that, we have to declare it over here, number, right? So we store it in there. So after we store the number of elements the user wants to enter, what we want to do is we want to just see out, enter your number, right? So it's going to see out, enter your number as such, and we want to add a new line over here. So when it outputs enter your number, that's just going to be once. But we want, if the user enters, let's say I want to enter 5 elements, and then it outputs enter your number, that's just going to be 1. So we'll just be taking 1 value, but we want to take 5 values. So what do? We use a for loop to print this the number of times the user wants to enter. So for, let's say, int I equal 1, what do we want to do? Okay, so for int I equal 1, then I should be less than, I should be less than or equal to number. That's the number of times the user wants to, that's the number of elements the user want to enter, and is the number of times you want to output enter your number, right? Then after that, we just want to increment I, and then we put in this particular line to kind of just keep printing this. Then when the user enters a value, what do we want to do? We want to take that particular value, and then we want to put it in the array which we have already created. So when I think we should use 0 over here, so that the first one, when I is 0, so when this will be I. So let's say for the first time, for I is 0, it would print out enter your number, and when the user enters their number, then it will be put in array 0. So in the 0th index, that's going to be the first element. Then it's going to come back here to +1, and it's going to check this condition. And so when I is then equal to 1, it would print out enter your number, and that value will take it and then store it in array index 1. That's going to be the second element. So it's going to be doing this. But take note that, let's say if the user enters number 5, 5 elements, right? Then this will be 0, that's first time, 1 second, 2 third, 3 fourth, 4. That's going to be 5 times. So we want it to be the less than the number, because from 0 to 4 is 5 rounds. So we want it to be less than the number. If we had started from 1, then we would need less than or equal to 5, because when if it's 1, that'll be 1 2 3 4 5, that's 5 rounds. But if it's from 0, so it will start from 0 1 2 3 4. So the fifth round is going to be on the 4, on number 4. So we want to use 0 here, because index here is going to start at 0, not at 1 as well. So take note of that. So then after we get these elements, what do we want to do? So after the for loop runs out of rounds, then we just want to see out whatever that they kind of gave the computer. So we want to see out array 1, and yeah, we have to use a loop here as well, right? So we just want to output those elements, and we can't just output 1 2 or whatever. So what we want to do is we want to use another for loop. So I'll just copy this and then paste it here, and then come over here and paste it, right? So then we want to, for I, for int I is equal to 0, I is less than, right, still less than the number, because the number of elements in the array is going to be equal to the number of entries the user entered to. So this is going to be retained, and so we want to just not enter number, we want to print. So let me just clear out all this. So we just want to print array of I. So when I is equal to 0, it's going to print array 0. That's the first element. Then it comes to I is equal to 1 2 3 4 as such. Then after that, what do we want to do? Yeah, I think that's basically what we want to do. So I hope you get the syntax. So we're going to run this, and we hope not to get any error. And there is an error over here, says expected semicolon before that. Where is that? Right, so over here. Good. We run this, and we're good to go. There's no compile time error. So how many numbers will you be entering? Right, but before we do anything, when we declare this array over here, right? Okay, let me just run it before any other thing. Sorry about that. So how many numbers will you be entering? Let's enter 4 numbers. Enter your first number, 1 2 3 4, and this and that and that. Why is it not stopping? We entered 4, and so let's see what's happening over here. So how many numbers will you be entering? We entered 4, so we said we stored it in number. So we said for I less than number, so less than 4, do this. and I don't think we're going to run out of this loop anytime soon. Right, so what can we do over here? I can see that we did not specify the number of elements that we are expecting. So let's say that um, now the thing is we don't know the number of elements the user will be inputting. So to be safe, for now, let's just input 10 over here with the hope that the user is going to enter a number less than 10. So we run this and we have, let's say, 4 again with this, with that, with that, with that, with that. And it's not still running out of loops over here. So what is the problem then? Int number, how many numbers will you be entering? So I think I have seen where the error is because I used C in over here. Should have been C out. So we want to see out the elements that we have just inputted. And to make this quite clear, let's just add this text over here that the elements you entered, or the numbers you entered are, then before we print all of those. Right, so let's run this and hopefully we should not be getting any error. And we have an error over here. It says that no match for this operator. So what operator? Yeah, I think it's this one. We run this again. Right, and now I hope this works perfectly. So how many numbers I'm entering? 3. Enter the first, second, third. Right. The numbers you entered are this. The numbers you entered are this. The numbers you entered are this. Okay. So this is not what I want. I don't want this phrase repeated. The numbers you entered are this. The numbers you entered are this. So what I would do is I would let's cut cut this and then paste it over here. So the numbers you entered are, and it's going to run this just once, and then I think I would issue a new line over here so that right. So before then it then starts to loop through this and then print them out, and I want to put in a tab over here so they don't get kind of mixed up. So we run this again. So I want to enter 4 this time. This is my first number, second, third, fourth. Right, the numbers you entered are this, right. So this is working perfectly good. Now let's say in the case the user enters a number greater than 10, what happens? So over here we specified that the array should have 10 elements. So what if the user wants to enter 20 elements? What happens? So let's run this and then input 20 and let's see. So I think I should reduce this so it's going to be so that it'll be fast. So let's say this is 5 and we run this and we want to input 6. Even 6 is still too much, right? So 6, 1, 2, oops, there's an error over there. Sorry about that. So you guys, you can go ahead and put in errors that if the user enters using the if statements, if the user enters a character that is not a number, then you can tell the user to check and then do it again. So you can use a while loop that while the user is entering non-characters and non-integers or anything, just have fun. So how many numbers will you be entering? You're entering 6. This is the first number, second number, third number, fourth number, fifth number, sixth number, and that. So 1, 2, 3, 4, 5, 6. So even though we specify that the array should have 5 elements, it allowed us to enter 6 elements. Good. Now what I have realized is if I put in 1 over here and I run this, and then let's say I want to put in 3 elements. I enter my first, second, third, fourth. Why is that the case? Fifth, sixth, seventh, eighth, ninth, 10th. It's not running out. Why is that the case? I just put in 3 here, but it doesn't seem to run out. So to check that, let's output the state of I over here. After we run every cycle, let's see what I is, because this condition should be violated, and when it's get violated, then it should run out of the loop. So let's see what state I is in. Right, so we can just output I over there with the new line command. Right, So to make this kind of presentable, let's make this state of I is right. So we run this. How many numbers will you be entering? 3. Enter a number. I'm entering this. State of I is 0. This state of I is 1. This state of I is 2. This state of I is 3. State of I is 4. State of I is 5. State of I is 6. State of I is 7. How possible? We said I should be less than number, and number is 3. Okay, let's change this 1 to, let's say, 2, and then run it again, because it was when I changed it this kind of error was coming. So we want to enter 2 this time. Enter your number, this. Right, so this ran out perfectly. The numbers you entered are this and that. So this was very perfect. Let me change this to 3. Run this. I want to enter 3. I do this, that, whoops, that. What have I just done? Sorry about that, guys. So how many numbers? Let me enter 5. This, this, this. State of I is 3. This. State of I is 4. Right, the numbers you entered are this. Good, so this is also running perfectly. Let's say I don't put in anything and I run this. 3, this, 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 this. So you see, this equally does not run out. The state of I is 9. When we said the state of I should be less than 3 as we have specified. Let me put in 1 in here. So you guys, you can see the errors that are coming up. These are runtime errors. So let's input in 3 over here. It's more than the number that we have created array 1 for. So enter your number. I'm entering this, 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 and state of I is 5 over here. It definitely violated what we said. So this is a violation, guys. I really do not know why this is happening. If you know why, you can just leave a comment in the comment section and it will be appreciated. Right, so this is an error that is quite accidental. I did not really expect this. But to just get back on track, let's say that we specify a number over here, right? We specify a number over here, let's say 5. For 5 is going to work perfectly. This is not a good practice to kind of give a number, let's say 4, and then the user enters a number 10. Now the thing is, if you just go ahead and put in 100 over here, a space of 100 stacks are going to be reserved for that particular variable. And what if the user just decides to enter 1? That means 99 of the stacks are going to be held and then they are not going to be used. So that is the disadvantage of using explicit static arrays or explicit static variables when you declare them as such. Now, we're going to go ahead and talk about the dynamic pointers, the dynamic memory, and how to use them. Now, over here, we want the space to be created in relation to the number of elements the user wants to enter. So if the user wants to enter just one element, then just one stack should be reserved for that particular element. If the user wants to enter 5, then 5 stacks should be reserved for that particular variable or what for that particular input. So how then do we do this on runtime? So when we run this and then we get the user input, let me run this. We get the user input. This is runtime. This is when the program has started execution. So then we get to state how much memory should be allocated during runtime and not during compile time. So that is the flexibility dynamic memory kind of provides. And so how we want to see how we can tap into this. So to begin, we will not be creating this array, so I would comment it out, but then we'll create an integer variable called number. Then we'd output how many numbers will you be entering, and the user is going to enter a number. Now what do we want to do with this number? We want to create a pointer to point to this number. And how do we go about it? We say int, let's say p1 is equal to the ampersand of number. Right, so this is a pointer P1 pointing to, let me kind of space this out so you guys, right. So this is a pointer, sorry, pointing to the address of the integer num1. But then we want to make this a dynamic memory allocation. So to do this, the syntax is after declaring your pointer P1 and you want to initialize it, the syntax is you precede it by new, and we can see that it's been deepened and it shows that it's a keyword and that has been recognized. So new, then the data type of whatever the user will be entering, and then with an optional parameter over here. So if the user is going to be entering just one number, then we wouldn't put this parameter over here, but it's safe to put it in there because if the user is entering one, it can still be one over here, right? So we want to then store the value the user will be entering over here. So right, this is the syntax. We create a pointer, and this syntax, you know it already. And there are three things you have to enter over here. The number of elements that this particular pointer will be pointing to, the data type of the elements, and what you just have to use to remember this is that this is a new memory allocation. You are now giving a new memory to this particular pointer. Then after that, we want to use a for loop to go through the number of elements the user wants to print, and then output this particular sentence so that the user gets to print. So it's going to be cn, and this time we will not be using array. We have already said that pointers work in similar ways to array, so we can just explicitly use p1 of I so that it will be stored at that particular place. Then I don't think we would want to print this, but let's just leave it state of I. Then after that, after we get the values, what do we want to do? We want to see out all of the elements. Let's say after getting the elements, you might have wanted to add the last two elements, add the first and last, multiply the second and third. That depends on whatever you want to do with the input. For in this case, you might go ahead to create kind of programs to do that what I've just said. But in this case, we just want to print them out. So we'll be using a for loop to loop through them, and we will be replacing this array with p1. Right. So this should not bring any error, hopefully. So we run this and we get the message, how many numbers will you be entering? And so we enter in 3. So when we enter in 3, it's going to take the 3 and then put it in here. So a memory of 3 stacks will be created for this particular inputs that we will be typing in, and that is the flexibility this kind of provides. So the numbers you entered are this, right? So this is the flexibility. You get to determine how much memory you will be needing on runtime. So we could have entered 100 and then we would enter 100 elements, right? So then this was the dynamic memory, kind of using it. Now, another powerful tool this provides us is that after we finish using this particular variable or this particular memory address, we can delete it, delete whatever value was stored in it so that we can use that memory again. Remember, when we used the array over here, after 100 stacks were reserved for this particular variable, and if the user just used 2 stacks of them, then 98 of the stacks will just be blocked. They will not be used again. That is the disadvantage. But for this particular dynamic memory, after we dynamically allocate the memory to whatever the user will be inputting, after using that space for whatever we want, let's say at the 48th line, we will not be using this array again, so we can delete it to free up space for other purposes. So then how do we do this? We just use the delete keyword, and I wrote these programs, these lines over here prior to this video so that I would kind of go by them. So the first thing I want to do is I want us to go exactly as I've written them here. So I would copy this because there are specific things I want to explain which I might have forgotten if I'm doing this on the go. So I'll paste this here. So this particular line is going to elements accessible before deletion, right? So let's say that we have printed this, we know what the program is going to do already. It's going to print out the elements that we have printed. Then after that, we want to see out the first element again. So we want to see if we can access it. So if we can access it, yeah. So we just run this, and then we have three elements, and enter your number. Sorry about this. I think I did not comment out. Oh, it was commented out. Okay. So I'm going to, let me just add some more edit over here. So the first element is right. So we have this, and let me space this out as well to make it presentable. Right, so I'll go ahead and run this, and then we're just entering three elements. So three stacks of memory will be reserved for this, for our entries. Right, so the numbers you entered are this, and the first element is 2, 3, 4, 5, as we have it over here. Right, good. So this means that we can access the elements. Now the next thing I want us to do is I want us to delete, use the keyword over here. I want us to delete, so go ahead, clear this. Whoops. So I want us to delete whatever was stored at this particular address, right? And then after that, we want to print the first element to see if we can access it again, to see if it's indeed been deleted. So we can go ahead and then put in here, I shouldn't have deleted the first line. So the first element is right. So so this is how to delete the contents of a dynamic memory. So you use the delete keyword, and then with the two square brackets with the name of the pointer. You can delete this as well if the pointer is just storing one element, but then you can use this and then just leave it as such, and then it's going to do the same. It's going to delete every element that is stored at the dynamic memory. So we run this, and if indeed the elements were deleted, then we wouldn't be getting the first element here. So I'm entering 3. This is the first, second, third, right? And now the numbers you entered are this. The first element is this. You can see these interesting characters that we have over here. Early on, when we looked at arrays, when you access an element which is outside of its range, you get interesting characters, as we have over here. So from this, I can say that we have accessed it outside of its range, and it's giving us um, interesting characters. So indeed, it's been deleted. So then let's go ahead and run the third line. So this third line, valid address after deletion. Right, so what will this do? So we're going to delete it, and then after deletion, what we want to do is, sorry about this, what we want to do is we want to print the memory address of that particular pointer to see if it still exists, to see if the memory address with the values were deleted, or it was just the values the dynamic memory was storing. So to do this, we would just be printing P1. So we are going to delete whatever thing is in it, and then we want to see if the memory address is still valid, if we can still use it. So we will go ahead to run this. Let me just delete this because this comment is kind of conflicting with what we're doing. So I'm going to delete this, and I'm going to run it. So we're entering 3 again, this. So the numbers you entered are this, and then with this character over here, with these characters over here. So this is a memory address. So you can see that the memory address is still valid, and it's called P1. So you can go ahead and use P1 again if you will be needing it. Mind you, whatever was stored in there was deleted, so that particular memory is free to be used now. Unlike static memory allocation where you can't use it again. This one we have deleted the elements, and we can use it and reuse it and reuse it again. Right.